Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Well, welcome everybody, and a big welcome to Reza. Reza was an intern with us and is at the University of Maryland, and it's a great pleasure to have him talk to us. So, Reza, over to you.
Thank you very much, Peter, for introduction, and thanks everybody for attending. I'm very happy to be here again. So today I'm going to talk about revenue-efficient mechanisms for online advertising. So first, I just want to quickly show the difference between algorithms and mechanisms for the people who might not be very familiar with the mechanisms. So algorithms usually assume that inputs are not intentionally manipulated. So they can have noise, they can have missing data, but they are not from an intelligent guy who changed them according to his benefit. But mechanisms, on the other hand, they assume that the inputs are from selfish agents and they have benefits. So they might intentionally change the data, they might change their values that they are going to represent to the algorithm, or they might hide data. So in summary, we can say that a mechanism is an incentive-aware algorithm. Okay, so let's see an example. Suppose we have a precious item, and there are some people who want the item, and we want to select which values the item the most. So here you see a robot which just gives the value, and you can see a poor girl which just honest and again just tell you the value that he put on the item, and we have a Scrooge McDuck. So what happens is that all the people here, they give their value to the algorithm, and then algorithm finds the maximum value and says that, okay, this is the winner, and we're going to give the item to the winner. And then as you can see, there is a problem here. Scrooge, as sees that it's just the maximum value, he changes value to infinity so that he makes sure that he gets the value. So there is a problem here because of the incentives of the people involved. So what we can do, we can change the algorithm to a mechanism which takes into account the possible incentives. So what it does, it finds the maximum value still, but it incurs a payment on the winners. And if you handle the payment, if the mechanism handles the payment in a nice way, then it will remove the incentive to lies. So if it is a good mechanism, then there will be no incentive to lie, because if you lie, you might be charged, and you don't want that to happen. So Scrooge will change his bid to his actual value. Okay? So this is mechanism.
Question?
Yeah.
So if I'm auctioning something, I don't really care whether the bidders are lying. I just want to maximize my gain from the auction.
Yes.
So I'm not sure why are you trying to incentivize truth speaking.
Yes. So that is like another objective. But for this example, my aim was to just find the maximum value. But that is good. I'm going to actually touch that.
But you're benevolent in this case.
Yes.
Right.
Here I want to just maximize the social welfare. I'm let's say government, and I want to find, for example, the people who needs a certain service like the most, right? So this is one example, but your example is actually what I'm going to talk about.
Okay.
So what I'm going to talk about is about online advertising that I'm sure most of you know. So this is a Bing web page, and I search hotel, and there are some ads which is shown here. It's sponsored links. So now So the other case is for a news website. If you see, for example, a BBC website, you can see a banner as an advertiser, or you can see some videos even as an advertisement. So essentially, online advertising is happening in lots of publishers' websites. It's even been in the mobile computing, and it's actually very targeted. For example, if they see that my location has changed to Cambridge and they find that, okay, I might look for hotels, so they target me for this website, for example, to find a hotel or a car or something else. They can see my location, my previous searches, so they can, for example, suggest me this insurance, and they can give me, okay, so you can just call it right away, or they can see the history of my application that I have installed and suggest me some applications. So advertisement has been in the mobile computing as well. It's also in Xbox. Xbox is also a very good example here, because in Xbox you can have multiple dimensions. For example, and they can target very well. For example, they see that what series that I have been watching, they know what music I have been listening, and they know what games I have been playing. They even know probably like my family, or if there are kids, like what kids have been watching, and they can target very well the advertisement. So it has progressed a lot, and there are lots of work that has been done in online advertising. And of course, it's a very important market. So first of all, of course, this is the source of revenue for many web-centric web-centric publishers. There are lots of companies who solely rely on the advertisement revenue. It's also very important for the advertisers. It's a main method for attracting new customers, and it also can be very useful to users to find their looking item very fast, and they see new product. Okay, so to just show you like how important it is, this is the total revenue of in online advertising market for each quarter. As you can see, for example, for 2014, for one quarter there is $12 billion. So in 2014, there are $48 billion in this market, which makes it very important and shows how so essentially the value that is in the market shows that it's actually extracting lots of value to the people, to the advertisers, and to the publishers. And then personally, I like one other impact that online advertising has been. It has improved innovation. There are lots of, as you might have noticed, there are lots of weblogs. For example, there are lots that gain revenue from this online advertising. There are like some, for example, YouTube channel that like an artist starts and put his works on that channel and gain revenue from online advertising. Or there are young singers who just starts and just gain revenue with this online advertising. So it has actually like progressed a lot and helped people a lot. So now let's take a look what our mechanism taking the role in this online advertising market. So as you see, there is a key component in online advertising, which is the mechanism which selects and prices the ads. Okay, and it's a very challenging task, because there are, of course, selfish advertisers and users involved. So it has to be a mechanism, and it has to optimize simultaneously the click yield or relevance to the users. It has to optimize revenue. It has to optimize social welfare, some of the benefits of advertisers and publisher. And because we have a limited number of slots, it has to be very precise on doing this optimization. And note that the slots might be very valuable. I heard that for some special medicine search or for some special like lawsuits, these ads can be very very valuable, and people bid a lot for them. And it's very diverse. So take into account for example, I mentioned that advertising happens in mobile computing, in Xbox. It is very targeted. There are like multiple dimensions that you can take a look in order to target the ads, and so on and so forth. So it's a quite challenging task. So let's take a look at the mechanism which selects and assigns the ads in the traditional advertising. So this is one page, and we have an ad slot of 3 text ads. Okay. What has been used so far is generalized second price mechanism, which does the following. It sorts according to the bids, the ads, and then whoever has the largest bid will be shown first, and then the second one will be shown in the second slot, and the third one in the third slot. And so if this ad gets clicked by a user, then he has to pay the bid of the second one. And then if this ad gets clicked, then he has to pay the amount of the third ad. Okay, so this is generalized second price action. So let's see what happens. So note that first, it's not actually the bid which is sorting the ads. It's a rank score. But for the purpose of talk, I'm going to just consider the bid as the value which with which we sort the ads in the slots. And it is without loss of generality, because if the rank score function is injective, then we can do it without loss of generality. So I'm going to assume that there is no ad effect, like probability of good click or bad click. It's just the bid that is there. And we have a slot effect, which is the probability of ad being clicked if it is shown on that slot. So the slot effect of the first slot is 0.9, then it's 0.8, and then it's 0.6. So
fixed numbers?
Yeah, there are fixed numbers for the purpose of that.
Okay. That's actually an effect, is it?
Sorry, what?
If you measure the number of clicks on the first and the second and the third, is it really, do you get stable numbers like this? Or?
Oh, it's just out of the experiment for a certain query, I guess. So for a certain query, you check the history and see like what is the probability of.
For a given query?
Yeah.
Oh, but for a completely new query, you
might not know that.
Okay.
That is like one other challenge.
These slot effects are the standard assumption is that they are the standard assumption is that they are somewhat static and they're independent on the query and the specific ad, mostly on the specific ad. And B, yes, they are quite stable. They're not. You change the page, then they change, but they are quite
fair enough. Thank you.
Yeah. So just for the sake of simplicity, we assume that these are quite stationary and there is no ad effect. It's just if your ad is shown in the first slot, the probability of getting lead is 0.9. Okay. Yeah.
I mean, because you are not taking into account the relevance of the actual advert while basically assigning the slots, it might be the case that somebody bids really high, but their sort of advert is so irrelevant to the actual query that it never gets sort of clicked, but still sort of is sort of put very high. And of course, this would not happen in practice, because normally there will be click-through rates which are multiplied to the bids to sort of get this effect. But so I see that you are working in a simple sort of universe, but wouldn't some of those effects, the click-through rate effects, sort of distort your analysis later on?
Yeah. So I told that what actually happens is the rank score. And rank score is like a function whose parameter is the probability of good click and bad click of that ad. And if that function is injective, then you can get the reverse of that, and then assume that that is the bit. So for the simple case of, let's say we have ad effect, and you can just multiply that with the value and get the value, and then think of that value times that relevance as the bit. So it's without loss of generality. We don't lose anything just assuming this. It just needs like a reverse function. After that, everything works generally. Yeah, but that's a good actual observation that, yeah.
But there is a slight a subtle sort of difference, because there are two pieces of secret information in the system. One is how the search engine actually assigns the score, right? And the other is what is the value that my competitors have who are bidding in the process, right?
Yeah.
And in many cases now, in the case where basically click-through was not taken into account and you were just assigning sort of slots on the basis of bids, then I would only need to know the information about my competitors to game the system. While in the other case where click-through rate is being sort of multiplied and you are getting a score, then you would need to also know information from the search engine, right? How the search engine is actually, what are the internal click-through rates or the relevance rates that the search engine is maintaining for each ad.
Yeah, that is correct. But I mean, usually when people like consider these auctions, they assume that they know like what is the actual bid. So in order to be like in a Nash equilibrium and everywhere, so the usual assumption is that they know all of this. But yes, you're right. It might be the case that they know the bid, but they don't know the actual values in the search engine. But usually they assume that if they are in Nash equilibrium, they know exactly what others are doing. Yeah. Any other questions? Okay, good. So yeah, so this is generalized second price action, and this is slot effect. Any question about general GSP? Everybody knows? Okay, good. So let's see an example. Suppose there are these bits, 10, 20, 30, and 40. And then, of course, it sorts according to the bits. And then we can compute the GSP payment. I always, when I talk payment in this lecture, I mean expected payment, because that is actually what advertisers and Bing see. So here in this case, with probability 0.6, this ad gets clicked, and he pays 10, so it would be 0.6 times 10. And with probability 0.8, this ad gets clicked, and he pays 20, so the expected payment would be 0.8 times 20. That is the GSP payment. Now, I want to quickly show that it might, the incentive to lie for the advertisers. So consider the same example. We have this bit, and we want to see if this is the actual value for the 40 guy, then we want to calculate what is the optimum bid for him. So if he bids 0, then he does not get into the ad slots, and his profit and payment is 0. If he bids 12, he go about this 10 guy, and he pays 0.6 times 10, which is 6, and then his profit is 18, which is 14 times 0.6 minus 6, which is 18. And then if he bids 22, then he go to the second slot, and his profit gets to 16. And then if he bids the actual 14, his profit is 9. Now you can see that there is the incentive to decrease the value in the GSP auction for these 40 guys. So it's just
only if these slot effects are pretty high, right?
Yes.
It's saying that in fact they add up to more than one. So this is assuming that everybody with probability 1 clicks on more than one advertisement.
That is unlikely that happens, but it's just for example. Okay. I wanted to show. Yeah, it's just small.
Hold on, that's not the point. The point is what Reza was speaking about earlier, that you can just, if you took these slot effects and actually had another factor applied on top of all of them, So take everything, say that the probability of actually clicking on anything is 0.01.
I see. Yeah.
And then multiply, then it's all,
Everything
this is
scales.
all without loss of
Everything
generality,
scales. I see.
everything scales. The
So these
bits
are not
become-
probability, they're just relative
Yeah,
values.
These are
Okay,
relative,
Yeah.
yes.
Okay,
Yeah.
that's the way to say it. Fine.
Yeah, but so the purpose is just to show that there is actually some incentive that might cause you to decrease your bid in GSP. Now that you have these incentives, what happens actually that the bidders go into a Nash equilibrium, which is the set of bids, so that nobody has the incentive to lie. Okay, so this is the concept of Nash equilibrium in nutshell. And then we know that the equilibria properties of GSP is well studied. Actually, there are multiple equilibria for the GSP, and these are well studied by Edelman and Varian. So in modern advertising, it's so in the traditional advertising, they usually call it position auction, where you had some positions and you want to assign ads. But in modern advertising, you can see that it's not that you have 3 slots to put the ads. You have mainline, via sidebar, and you can have, for example, answers instead of ads, so on and so forth. So it's changing. And I want to argue that GSP does not work well in modern advertising. So the first reason is this problem of sidebar mainline. You can see that the bids of, for example, advertisers who are assigned to the sideline is not implying a meaningful price rule on the mainline ads. So it's not like the position auction, which you can imply those rules. Also, it is not well defined across templates. This is actually a work done by people here, Yoram, who is not here, Sophia, and Ian, and Peter, and David Korkova, which shows that essentially you cannot generalize well when you have different templates. For example, to see an example, consider image and text case, where you have the ad slot. You can either put an image ad or some text ads. So what happens is that here, you can either put this image ad or put these 3 text ads, and you can calculate like which one you prefer. Then if the text ads know that they are in this auction, this 20 guy might change his bid to 26 because it doesn't change his payment. He has to still pay this 10, but it will incur more charge in the people above him and then make sure that they win against the image ad. So this is another problem I just wanted to show. The other problem that I think is the most important one is that now that bids are tailored for GSP, they cannot be used in the different services. Eventually, we want to unite all the bids so that we can use our ad inventory across different services. For example, we might want to use them in MSN, in mobile, on Xbox, and so on and so forth. But if they are tailored to attending GSP auction, then you cannot use that. It's also, as I mentioned, that because GSP has multiple equilibria, the amount of revenue you get is dependent on the user's strategy. So you are not sure, like, either you're getting good revenue or it might decrease, because it's just all dependent on how people or how users strategize over bidding. And then, so why people usually use GSP? Because it gives more revenue, essentially, if you use a truthful auction like VCG, because usually it gives more revenue. But what I want to argue is this revenue equivalence theorem, which says that if 2 mechanisms are giving the same allocation, then if the bidders are playing optimally, they have to give the same revenue as well. So in theory, you should not get more revenue from GSP than VCG. But VCG is Vickery-Clark-Grew auction, which is a truthful mechanism that maximizes the total value of people who have been assigned. So it's the same as GSP, but the payment is in such a way that the best strategy for everybody is to just tell the true valuation. I'm going to be more precise on that, but But I just want to make the point that people use GSP because they expect more revenue. That is correct. But I want to argue that this actually hurts small businesses, because by this revenue equivalence theorem, it says that if people had played optimally, then they should not give more revenue to you. If you are getting more revenue, it means that people have not optimized their bid. So it means that they're probably small businesses that are not doing that. Okay? So GSP does not work. So we need to go to another mechanism. Now I want to argue that that has to be a truthful mechanism. So the first reason is that you can't use the same strategy everywhere. You can just tell your true valuation and it works everywhere. So it will solve the problem of sidebar vs mainline, because again, you have the true valuation and you can just use your truthful mechanism to assign the bids there. And it's also, which is very important, you can use the ad pools everywhere for any service you have, for Xbox, for MSN, for any service. It also removed the computational load from advertisers. Now they should not be worried about computing the optimal bid. And it makes your market very transparent. And if the market is transparent, you can better understand the market because you know the actual valuation. So you can have meaningful reserve price, and eventually you might increase your revenue by having those reserve prices. So now I'm going to, yes?
But will a truthful mechanism lead to reduction in revenue in the short term?
Yes, it will. I'm going to show some experiments that show that it is actually.
Will that hurt the incentive to actually use them?
It depends on the company. In my opinion, it should not do that, but
I guess do you have some evidence that the better understanding of the market will lead to greater revenue in the longer term, or is that a qualitative argument?
Yeah, I believe so, but I don't know how to experiment that. You know, it's a hard task. But usually, if you are having a good social welfare, large social welfare, it means that you are going to get more revenue. Large social welfare means that if you have a transaction, like if you're showing a web page and you are showing some ads, and that transaction has a large value, it means that the society are gaining more, and they tend to attend to your auction more, and then in long term you get more revenue. But it's hard to measure really, especially in long term, right?
Also a good argument for that. Because we can generalize GSP, there's no way for us to take GSP and to innovate or explore new types of ads or new types of templates. However, if you move to a truthful mechanism, you could. So there is another gain of revenue coming from this ability to do that.
That's a very good point. Essentially, it's not possible, like GSP, because GSP is just for that traditional advertising. But that's very good. So now I think I'm quite slow. So I'm going to show the outline of my talk. So first, I want to show you how we can make this transition from the GSP mechanism to a truthful mechanism. This is joint work with Yoram, Sophia, Ian, and Peter. Then I'm going to talk about, okay, when we transition to truthful mechanism, there are still lots of problems, especially in modern setting. I'm going to touch revenue monotonicity and revenue efficiency in this modern setting, if time allows. Then I'm going to talk about my future plans. So for the people who might not be very familiar for truthful mechanism, I'm going to quickly introduce what is truthful mechanism so that you don't think it's a very fancy thing. It's a work that has been done with quite a lot of time. Start with Vickery, then Clark, grew, and end up at Mearson at 81. So think of a mechanism that is assigning some items to some bidders, and then the bidder comes and he optimizes his bid and then give bid B1 to the mechanism, and then the other bidders come and they also optimize their bid and give to the mechanism, and then mechanism selects that item I1 is going to the bidder 1 with payment P1, I2 to bidder 2 with payment P2, so on and so forth. So this is the mechanism which might not be truthful. It can easily be transferred to a truthful mechanism, but just saying that, okay, I as a mechanism take your true valuation and I myself will optimize your bid. You should not worry about optimizing your bid. I will do that for you, myself. So you can easily transform it to a truthful mechanism. And that's actually the idea behind like most of truthful mechanisms. And it's known as a revelation principle. So it's just to keep in mind like what is truthful mechanism. It's the case that, okay, we do the optimization. The advertiser should not worry about that. Okay?
So I was assuming that you started off by saying the advertisers might lie if they have an incentive to. So
yeah,
assuming that you know their true values is kind of like a funny starting point, isn't it?
So the thing is that I will promise them to optimize for their true value. Okay? So if they lie, it means that I am optimizing for some other value which is not the true valuation of that guy, and it might hurt him. No matter if he tells the higher amount or lower amount. Because I'm just optimizing for another value, then it might hurt him. Suppose you have a function profit of V, then I'm optimizing that function for V. Okay? So if you tell lie, I'm optimizing for other value. It is not your true value, so it will hurt you.
So you want to tell the advertisers to just trust me, I'm going to do the best thing for you.
Yeah.
I'm not, for example, going to say, oh, you're from Google, I'm never going to display any of your adverts.
No. If you do that, your mechanism is not truthful. You have to have this promise that you honestly optimize. If you don't do that, then it is not truthful.
And what's the criterion for optimal then?
Optimal means that, okay, if you fix all the values, okay, and then from each advertiser's point of view, this is the best bit that you can put in the system so that it maximizes your profit.
I mean, if I just think of it as a black box, he tells me the values and he outputs them out.
Yeah, so think of...
Never mind the stuff inside.
Yeah, think of GSP mechanism. So what happens is that, okay, I get some values, and then I want to assign the ads to the slots, right? So you give me the values, okay? I know the values of the others, and I'm going to find the best slot for you so that you gain the highest profit according to that value. So what would be your best bid in the GSP so that you get the best slot? So I'm going to do that for you. Like whatever. So this you can also think of this way. What you have been what you had done if it was your choice to give a bid. You will maximize according to some algorithm, right? And then I just include that algorithm in the mechanism. That makes it
some fixed mechanism.
Yes. You have to assume that fixed mechanism.
Okay.
Yeah. So it's not fancy. It's a truthful mechanism. So let's go back to the transition. So we have a current inventory of bits tailored to attend the GSP mechanism. And we want to make the transition to a truthful mechanism. And of course, we want to encourage advertisers to change bits to the true valuations. So we start the transition at a certain time. We say that, okay, at this time, we are transitioning to a truthful mechanism. And from now on, it's better to change your bid to the true valuation. And then when advertisers adapt to the new system, then we treat her as a truthful bidder. So we optimize her profit. That might change his position and payment, but we optimize. Again, that point is important. So from this point, you have to see that, okay, all advertisers have incentive to change because we're just optimizing their profit. So it means that if the transition happens, it is in their best interest so that they come as soon as possible and update their bids to the true valuation. Okay? And that's just direct result of the optimization we make for their value. Okay? So, of course, there are difficulties involved. Advertisers may not adapt fast. It might be the case that during the transition you have some GSP bids, some true valuation that from the advertisers who have adapted. And the second issue is that do they actually update the true valuation? Do they trust us? Do they know the true valuation, their own true valuation? They might not know. They might trial and error. And the third issue is that how much revenue we might lose during the transition. So let's see the problem statement. So the problem statement, yes.
Should we add to this list of problems also that advertiser may have different target functions? So it may not be that they want to optimize for profit, but that they have some bizarre internal optimization criterion, so that they say, I'm just interested in my number of impressions.
Yeah, that is correct. So yeah, that's a good point that they might also interested on that.
Doesn't that translate to a different value?
Yeah, so
Well, it is possible then that you may have to you may be able to reformulate it as a very specific value. Per
No. I'm saying any profit function.
yeah.
Well,
Yeah, but
okay, not any profit function.
Optimize for
No.
some.
But it just means that their value is different, or
Right.
under
He
some
will
Yeah, I guess-
pretty simple assumptions on the profit function. If it's simple enough, if it's completely wacky, I don't know. I like 100 impressions, but I don't like 101 impressions. I'm sure we can't find a solution. But I think under very simple assumptions on the profit function, it just means that the true value is different.
Yeah, that's. So essentially, yeah, it's very good. So it's essentially like what I told in the beginning as well. So if you have a function which represents your profit, then you, as far as it is injective, it's one-to-one. Then you can change it in a way so that the value which optimizes for the like linear, quasi-linear profit actually represents that profit function that you are looking for. So it just needs the transition. But I agree that like inside our mechanism, we assume that the value is just aimed for to optimize the profit, which is click-through rate times the value minus the payment. But it is without loss of generality. So we have a mixed set of n bidders. So this is the problem statement. So we have a mixed set of n bidders. Some of them are adapted, so they have their true valuation in the system. And some of them are GSP bidders, that they are advertisers who have not updated their bids. And we have positions index 1 to k, with position 1 having the highest click-through rate or slot effect. Position I, so these are the positions. And then we want to give a mechanism that assigns the positions to the advertisers. So note that in this mixed setting, we cannot just sort them by their bids. This is usually what happens in truthful mechanism design, that you give the allocation and then the payments will be uniquely identified. But this is not the case for this question because we have a mixed nature of advertisers. And then note that what is the implication of a GSP ad? So if you are a truthful bidder or adapted user and a GSP guy is below you, then know that it is implying some payment constraint on you, right? So if a GSP guy is below you, then it means that it's implying some payment constraint, okay? So this inspired our work to give a payment framework, which is the following. So we asked the designer to give a function pi for each position I, which is a function of the ads that are assigned below you. So if we know that the ad assigned to position Vn is a truthful ad or adapted ad with value Vn, so now his value is equal to his bid. And then there is some GSP bid with bid Bn minus 1 all the way to value to the bidder who is assigned to position I plus 1. Then the designer how to give us the function which tells the payment of position I. So what we need from the designer is to just give us these payment functions. For example, a simple one is that, okay, if a GSP guy is below you, you have to pay at least his bid, okay? Then we know that it can also be generalized to more than like 2 type of bidders. It can, for example, include first price bidders, the advertisers who have contract and they pick first amount. So this payment framework works for them. So the advertisers have to give us these payment functions. So of course, it cannot give any payment function. It has to have 2 properties. The first property is exact marginal increase of the payment, meaning that if the advertiser who is assigned to position I has value V, then the marginal increase of the payment for the next position has to be exactly V. So this is the first property, exact marginal increase. And then the minimum marginal increase.
You're saying it's obvious that it should have that property?
Oh, so yeah, so.
Why is it obvious?
Huh?
Why is it obvious that it should have that property?
So it's a little technical, but not that much. So if it is more than V, then it makes an incentive for people to lie. If it is more than V and your value is something a little bit more than V, then you have incentive to bid less than V and go below him. If it is more than V, if it is less than V, then you have to incentive and go above him. So it's a little technical, but.
Okay, that's fine. So it's technical rather than obvious. Thank you.
Yeah, that's correct. I should not write, is there obvious here? Oh, I told obvious. So yeah, I should not say that. And the second property is that the minimum marginal increase, which says that after you pass truthful or adapted users with value V, the marginal increase from now on has to be at least V. It cannot go down to less than V. Okay? So if the payments satisfy this, then we can show that any mechanism obtained from our framework is truthful for the adapted bidders. So they don't have any incentive to lie. Their best interest is to tell the true valuation. And then we show that these 2 mechanisms, these 2 constraints are not actually limiting the hand of the advertisers to design a mechanism very much, by showing that this framework is actually can implement any mechanism which is intermediary free or whose payment is dependent only the people below you. These are the 2 theorems which are technical. I'm not going to touch, but yeah.
So the exact marginal increase mean that given the truthful bidder, and if I know the price of the truthful bidder, I automatically know the price of the guy above him.
Yes, that is correct.
Well, the exact marginal increase actually encodes this optimization that we're doing for the bidder in order to maximize their profit.
Sorry, say it again.
Your exact marginal increase criterion encodes that we are doing the maximization or like the optimization on behalf of the advertiser in a way. Or at least this is how I understand this criteria. So the marginal increase of payment means the price for the next click that I can potentially buy. If that click is more costly than my value, I'm going to lose. Mm-hmm. So I better not do that.
Yeah.
If my next click is cheaper than my value, I'll make at least a non-zero additional profit. Mm-hmm. So it's better for me to increase my bid.
Yeah. So it's interplay of 2 advertisers. So it means that if I am bidding V, then no one else other than me has the incentive to go over me or below me. If he has a more value than me, it's better for him to go up. If he has less value, it's better for him to go down. It's like interplay of 2 people. If it is not the case, then if you fix your value, the other guys might change.
Right, but yes, the moment I compute the marginal increase, all of the other players come in a way.
Yeah. All the other players will be like put in their position, in their correct position. Okay, so these are the properties of payment framework. So we especially designed the hybrid mechanism from our framework, which is the following. So first, remember the Nash equilibrium is an equilibrium where nobody has incentive to change. And then suppose that advertisers has optimized their bid flawlessly. So more formally, they play a symmetric Nash equilibrium with minimum revenue. So this is the best, the best bit that they can put. So we essentially invert this, this function, which takes the value and put the SNE bit, and put this as a payment function, and get the hybrid mechanism. So if bidders had played this minimum symmetric Nash equilibrium in the GSP, then if you use the hybrid mechanism in order to make the transition, then you will not see any change in the allocation. You will not see any change in the payment and any change in the revenue. So the transition will happen without any notice. But if you just switch to the VCG right away, it can have arbitrary bad revenue. Okay, so this is a hybrid mechanism in theory. And in practice, we implemented the following mechanisms. We implemented the hybrid mechanism, the GSP mechanism, the VCG with bids, which VCG is the mechanism which assigns the bids according to their, assigns the advertisers according to bid again. But instead of the GSP payment, it computes the truthful payment. Okay?
So you said before that if you run the hybrid mechanism and the players play minimum Nash equilibrium, then we get the same revenue as GSP.
Yeah.
However, if we switch directly to VCG, then we can get arbitrary bad revenue.
Yeah.
However, if all the ads are being true, if you in the hybrid mechanism, if all the ads are truthful, you're basically running VCG.
No. So in hybrid mechanism, so I mean that people had played flawlessly, meaning that they get the value and their bid, their symmetric Nash equilibrium.
Right.
So their bid is less than their value.
It's a symmetric Nash equilibrium under GSP.
Yes.
Right? And right, you're saying if I took this symmetric Nash equilibrium and now applied it on VCG, take these bids that were optimized for GSP and apply them in VCG, then I would lose money.
Right.
That's right.
But
Yeah.
in the hybrid mechanism, you then need to define if you take all the players,
Yeah.
and the players optimize their bids for GSP, and then you take them and you place them within the hybrid mechanism, then you also need to specify which one of them are we considered truthful or not. If
Yeah.
you consider all of them as truthful, which means that we basically, even under the hybrid mechanism, we run VCG.
Yeah. So in hybrid mechanism, the assumption is the following. You will start with the current bid. So now nobody is adapted. So I think of all of them as GSP. So the property of the hybrid mechanism is that it will be the same as GSP as far as no one has updated. As soon as the first one updates, we will think of that as a truthful bidder. And from now on, we optimize his payment and function. And then
all those guys from the GSP that optimize for GSP auction, and then you place them within the hybrid mechanism. All of them are all of the ads are non-truthful.
Yeah.
Then you lose nothing.
yes, it's the same as GSP.
Yes.
Yeah. So yeah. Okay, good. So we implemented these 4 mechanisms, and then we analyzed the revenue, social welfare, and click yield of on the assumptions that advertisers directly update to their true valuation, or they are cautious and they do trial and error for their valuation, and some other assumptions. So I especially want to show the revenue analyze for you because the social welfare was essentially the same, and the click yield was, we didn't have any noticeable differences. So in revenue, so this is the number of updates. This is the first update, second update, all the way to 12 updates. This is the VCG, if you just play VCG. And this is our mechanism, the hybrid mechanism, which is essentially saving. And the yellow one is the GSP, and the green one is the actually VCGV. So I think I forgot to mention that the values are here from the works of Peter and Pin. So I said that if the values are taken from that symmetric Nash equilibrium, the invert of symmetric Nash equilibrium, nothing changed. but that is too good to be true, right? So we take these more realistic values, which essentially says that if I know the slot effects and the distribution of the bits for other people, what would be my best bit in the GSP? And then revert that, you take the value. So it's an estimate of the value. So this gray curve here shows that VCG value after everybody have updated. So the hybrid mechanism start with GSP. So note that if it is 0, then the hybrid and the GSP is the same. And then at the first update, it does that and go all the way like that. Yeah.
Can we elaborate more on this graph, right? So you use real data,
Yeah.
which has the bids as they are, and some estimation of the value based on Peter's work from 2011, and then you have your 4 different mechanisms.
Yes.
And what do you play here?
So here, so it's actually rank scores. So it's not bid anymore. So we take this like the inverse of rank scores. And then we run over like 37,000 different auctions that are from the Bing data, actual data. And we ran these 4 mechanisms. What we do, we randomly shuffle the players and say that, okay, these are the order which are going to update their bids, okay, in these like 37,000 different auctions.
And every time an update comes, you switch from the current bid to the estimated value.
Yeah, directly to the estimated value. And then these are the average revenue in percentage for GSP, for the VCG with value, for the hybrid mechanism, and for the VCG with bits.
Okay, so GSP there's no changes, right? It's the current revenue, and everyone stays with the.
Yeah, that is our benchmark, which is like the highest revenue you could get.
VCG with -V is if everyone immediately played the value you estimate that they have.
Yes, exactly.
Okay. Hybrid is everyone starts with the current bid and they gradually shift.
Yeah.
And VCGB is the same thing, but you apply the VCG mechanism.
Right away.
Okay, understand.
Good.
Thank you.
Yeah, thank you. It's, I think, now much more clear. Yeah, I think I have to wrap up. So this is the cautious bidders. So it's essentially now they don't directly update to their true value. They try to, they do trial and error. If they see the lose in the profit, they tend to update their bid more. They don't update the true valuation. They increase their bid. So this shows how these 4 mechanisms do. And the conclusion of the transition part is that the payment framework in theory only requires payment interpretation, guarantees truthfulness, can implement rich class of truthful mechanisms, and the SNE simulator with the SNE bid assumptions, nothing changed, and it encourages bidders to adapt. And then the payment framework in practice, we don't know the true valuations, certainly, and we don't know the behaviors, but there's the loss of 5-10% in 10-20 runs. I guess I'm not going to touch the problems of truth mechanism in richer settings, so I might just quickly go over them for the sake of time. So I just want to quickly mention my enthusiasm about the Microsoft. So first, I have background in like optimization problem, parallel algorithms, incentive-aware algorithms, machine learning. And I guess Microsoft presence in these lots of areas, like desktop softwares, all these areas will lead to lots of interesting questions that I'm very interested to work on. For example, to just give an example, I want to see like a study on Xbox pricing model. You know that there are like spectrums of model. At the very left, you can see search engines which you don't get paid by service at all, and your revenue comes from just advertising or games model, which you give away your game for free and then hope that people buy some premium bundles and you gain revenue by that. And the other end of the spectrum is the hardware model, which you gain all your revenue by just giving your service. For example, if you are a mobile producer and your cost is 300, you sell your mobile phone with 400 and you gain 100 revenue. So this is 4 to end. And we know that the Xbox pricing is somewhere in between, but I'm not aware of like any study which shows that this is the best model for pricing Xbox, for example. It has to go nearer to the search engine model, which encourage people to buy more, and then Xbox can improve his presence in, for example, music, movies, and games, and so on and so forth. So it will improve its appearance in the market, and you can gain more revenue by the second source of revenues, like advertising or like buying in the market. So thank you very much for listening. If you have any questions.
Any questions? Yeah, Danny.
So I struggle to see how, assuming that a user knows their value function is reasonable. I'm imagining running my website, I get some clicks, and I can maybe measure what percentage of them lead to sales, and I can measure the profit of that. But there's a lot of uncertainty I have about what the actual value is. And so is there any sort of space for having uncertain values from the advertisers in this setup?
So you mean like that the advertisers do not know their value and then what they should do?
Yeah, I'm trying to learn my value as I'm getting clicks, right? So I don't know how likely somebody will buy a product coming to my page.
Yeah, I think that is exactly what actually happens in practice, that you increase your bid and then you monitor like how much your sale, for example, has gone up, and then you see how much you are paying to the publisher website, and then you see, okay, is it good for you or not? But honestly, I'm not sure. I'm not completely sure if the users can actually see that, like what is the actual percentage of the visitors who will lead to the sale or something. So they might know this. It's not very hard to see like what is the percentage. But from the search engine point of view, I think you can measure like how long the users have been in the website. And for some special website, you can also measure if the transaction has happened or not. So they will send like a JavaScript sign that.
Thinking of the case where I just started running this. I've gotten 5 clicks, 1 person bought, and so I could say, okay, 20% of people are going to buy, but I would be happier if I said I have some belief about the probability that people are going to buy, which is some probability distribution. And so is there a way for me to express my value as a probability distribution?
Yes, so for example, if you know that like 5% of your visitors are buying, and then you know how much you are paying to the search engine, then you can calculate your value, right?
But I'm uncertain about what the true percentage of people will buy is.
Oh, I thought that you know about that.
Well, I'm estimating it from a very small sample size so that I have uncertainty about it.
Yeah, that uncertainty is always there. So this is the actual thing that you have to do. You have to calculate that percentage that people will buy, and then according to that, you can calculate your value. But I guess you can make it more precise over the time if you have more history, but always there is uncertainty, right? Or you can, for example, target better to make it less uncertainty. For example, say, okay, just show my ads to people in this city, or other methods. Yeah, but it's a good question. I guess there are some studies on that what would be like the optimization criteria for the users in the literature.
Okay, thanks very much. Thanks, Reza.
Yeah, thank you very much.